Here are some examples from section 9.1 now that we know the vocabulary behind a quadratic. So in this first example, we're going to use the picture on the right here to identify the vertex, the axis of symmetry, the y-intercept, and if we have a maximum or minimum and where that maximum or minimum is at. Okay, so notice that the vertex, remember, is always going to be either the highest or the lowest point on the graph. Notice that my picture is opening up, which means that there's going to be a point that is at its lowest. So that means we can actually answer the very last part between a minimum or a maximum. If it's going to be that there's a point and it's located, hopefully we all notice that it's right here, that we have a minimum in this problem because the graph is opening up. So really, if we want to identify that minimum, it is also the vertex. So by us identifying that lowest ordered pair, that's going to give us the first and the last answer. Well, remember, an ordered pair is always x, then y. On the x-axis, we have to move over to -2. Then we have to go down 1. So it looks like -2, -1 is the vertex, which also then happens to be the point where that minimum is taking place. Okay, notice that it's not drawn in the picture, but it's a good idea to maybe draw it. If we know where the vertex is located, the axis of symmetry is always going to be a line, a vertical line going through that ordered pair. So notice that it would have to go through the vertex right here. So it would look like this. An axis of symmetry will always be in the equation x equals a number. And so for us, once we've identified what the vertex is, remember, an ordered pair is always x first and y second. Well, because my axis of symmetry is x equals a number, and that has to go through the vertex, it's going to go through the x value of the vertex. So since my vertex is -2, -1, x equals -2 is my axis of symmetry. My y-intercept is always going to be the ordered pair that is on the parabola that is touching the y-axis. So I know it might be a little bit hard to see, but hopefully we notice that it's right here that it's intersecting the parabola to the y-axis. So remember, it's going to be an ordered pair where 0 is going to have to go first. I didn't move left or right, and I moved up to get to that +7. So there's all the information with this first picture. So if we move on to the second picture, it says use the picture to identify the following. Here, I just want us to identify the vertex, the axis of symmetry, or if we have a minimum or a maximum where it's at. Notice that I didn't ask for the y-intercept this time, only because I didn't also give you an equation for what this parabola is, and our picture doesn't show it going through the y-axis. So that's the only reason why I left the y-intercept off on this one. Remember, to identify the vertex, it's the highest or the lowest point. Hopefully we notice that because my graph is opening down, it's going to be at the highest point. So hopefully we're all okay with it's going to be this ordered pair right here. So that really means then we're going to have a maximum. So that point here that's at its highest is also the vertex. So if we identify that ordered pair, remember x is first. So it looks like I had to move over to -3. And then I had to move down to get to -4. So that would be my vertex, which is also where that maximum value is at. Just because it's not drawn in the picture doesn't mean that we don't know what the axis of symmetry is. We could sketch it in. It's always going to be a vertical line going through the vertex. So remember, it's always going to be x equals a number. And because I know that it's going through the vertex, it's going through the vertex at the value of the x from my vertex, which is -3. So there's all my information. The last problem here is wanting us to describe if the parabola has a minimum or a maximum, as well as if it's opening up or down. So remember, for us to identify that when I'm not giving us a picture, we have to look at the equation, and more specifically, we have to look at the a value. So just another reminder, it's always y equals ax squared plus bx plus c. So the a is always in front of the x squared. So in part A, if y equals negative x squared plus 8x, hopefully we're okay with it being a negative, or really a -1, which is my a value. And so hopefully we notice that a is negative. And so because a is negative, that means that my graph is going to look like this, which means that my graph is going to open down. So if it opens down, that means that we have a point that it's at its highest. So that means that we are going to have a maximum. So remember, I wanted both things. I wanted, is it a minimum or a maximum, and does it open up or down? So I've identified both of those pieces. Notice that the next equation says y equals 4x squared plus 3x minus 1. So once again, if I look at the a value, which is in front of the x squared, I see that my a value is a positive number. And so anytime my a value is positive, my graph is going to look like this. It is going to open up. And because it opens up, that means that the point that I'm looking for is at the lowest point on the parabola, which means that we are going to have a minimum. And then finally, our last problem here, if y equals 1/2 x squared plus 12, even though this is a fraction, I'm just identifying the number that's in front of the x squared as either positive or negative. In this case, it is a positive. So just like our last example, that means that our graph is going to look like this, which means that it's going to open up. And that means that there is the lowest point possible. So we have a minimum.